Hello everybody, I'm going to take you through a quick Carve Pro, what it looks like, how to model something in Carve. So Carve Pro looks like this right here. It's this little blue flag looking guy. It's also down in the taskbar, which is not being recorded, but you get the idea. So first thing I'm going to do is create a new file. I'm going to do a single-sided job. This right here, width, height, and thickness, is you can show in this little pictorial here. That is the size of the workpiece I'm putting on the router. So whether it's foam or wood or plywood or plastic or whatever it is, this is the exact size of it. Width and height, you can measure those with a tape measure. Thickness is pretty important to measure with a dial caliper because sometimes you think it's 3/4 of an inch or 0.75 inches thick, and it's not. It's actually 0.74, or maybe it's 0.76 or something like this. What's going to happen when you try to machine that is you're either going to cut all the way through it and you're going to cut into the table, or you're not going to cut all the way through it and you're going to be left with this little thin piece of material that's left. So that right there, that thickness is really, really important, that you accurately measure that with a dial caliper. These next two boxes are my 0 position. You can see this red dot down here. This is going to where the router is going to determine its 0 point is, so its datum point. So this is like its home base. This is kind of like where it starts from. And that's important that we use that lower left corner because we have a probe that fits on that lower left corner that the machine will automatically go and find this for us. So it's pretty accurate. And I'm going to go ahead and hit OK on this. There we go. So file operations at the top: cut, paste, copy, undo, redo, import, save. If I need to modify the piece size again, I can go right here and edit that. I can create vectors, which is what I'm going to show you how to do. I'm going to start with a rectangle, right? You can do just a regular square, an external radius corner, or an internal radius corner. Okay, I'm going to do an internal radius corner because it looks like a little plaque or something. I can set my size here, or I can come over here and I can draw the thing. So either way, I can actually create something here. And what I can do, if I don't want the rectangle tool any longer, I hit escape, or I can hit OK at the bottom. If you click once, it turns the vector pink. You click again, you get these little nodes that pop up. This is how you can transform and stretch and move to make this bigger or smaller. If you want it to be an exact size, you would select it. You would come down to transform objects, select object size, and you can type in the exact measurements that you want, and it will create the rectangle of that size. Okay, be careful with this link X and Y. Right now I have a proportion between 7 in the width and 6 in the height. If I click this and I change that to 9, it automatically changes the other one as well. Okay, to maintain that proportion. So I'm gonna just undo that because I want to work like this. All right, cool. So now I've got a rectangle with corners missing. So I've got this little like plaque thing. What am I going to put on the plaque? I'm going to put something on it and make it, embellish it a little bit. I'm going to just add a little bit of text. So I'll click draw text and I'll write Spartan STEM on there. Okay. You can change your font in here. There are hundreds of fonts. Pick one that you think looks cool. I would stay away from the generic default like Arial or Times New Roman. I would go and try to find something that's maybe a little cooler. Right, it's up. This is a personal choice. It's up to you. You can bold your font. You can italicize your font. There's a whole bunch of different things you can do with it. You can set your text height. So this is the height of the actual letters. It's 0.76 that I've made it. No, one's too big. Won't fit on my work here. So let's do 0.75. There we go. Again, I can also like move this around, kind of get it lined up where I want it. There will be a little line that sort of shows up when you get it in the middle of the workpiece. not necessarily the middle of this, but I can show you how to line everything up shortly. So I'm happy with that text. I'm gonna hit close. How do I line all this stuff up? Right? If I highlight everything down here under transform objects, the very last one, align selected objects. I align that. Let's go ahead and just align this one. Okay, so that's exactly in the middle of the workpiece. And that's exactly in the middle of the workpiece. And if I like that, then I'm happy, then I'm good. If I wanted to maybe adjust this and move it up or down just a little bit, I can use my arrow keys to kind of move that up and down a little bit. So if I offset it a little bit, this is kind of a whatever it looks good to you deal. Now I've got a rectangle pink line, and I've got some text. So when I click on it, it will become pink. That's important for the next step we're doing. We want to have the router cut this out. So I go to Toolpaths, and click that little tiny auto hide button in there. It makes it so this menu doesn't disappear every time. I'm going to think real quick about how I'm going to do this. If I cut this out and then I try to carve the letters, it might not be holding on to a whole lot of material. So it might break, it might move. So I got to think backwards a little bit. I'm going to cut the letters first, and then the very last thing you always want to do is cut out your shape when you're using this CNC router. So I'll go ahead and highlight my text, and I'll come over here to VCarve. My start depth and flat depth, you can play with these settings and see if the desired result is what you want. That's generally what I do. If I don't like this, I'll maybe go and add a flat depth. A flat depth tells the machine you're only going down this far. Your tool should be the V-bit 90-degree half-inch. There is a tool library where we could maybe use a 60-degree bit or a much larger 1¼ bit, which is again much larger for doing large signs for fronts of businesses and that kind of thing. I'm not going to use a clearance tool, and I'm going to scroll all the way down here and click calculate. So here's what's happening. The machine has created a map, so to speak, of where the tool is going to go, and now it's showing me that map. This is a 3D view, so if I rotate this around, I can see that I got different colors here. Red lines are where the machine is moving rapidly. It's going as quick as it can to from one location to the other. Green lines are where the machine is going into or out of the material. And the blue lines are where it's actually cutting. So if I just click Preview All Toolpaths, it will give me a pretty good picture and a pretty good idea of what this is going to look like. So right now I've just got letters, and I'm happy with that. So I'm going to hit close on this preview menu. How do I get back to my 2D view? Is up here at the top. So I've got my letters done. Cool. I still got to cut this thing out. Now I'll select my outside shape that I want to cut out, and I'm going to choose Profile Toolpath. A Profile Toolpath basically follows the line. A Pocket Toolpath will cut away material from the inside of the line. So you don't want to do that because we have text in there we don't want to get rid of. So I'll click a Profile Toolpath. Cut depths. Your final cut depth is the thickness of your piece of material. Remember I talked earlier about measuring that accurately? That's important because this number needs to match your material thickness. There's the tool I'm going to use, my 1/4-inch end mill. I'm going to cut on the outside of this. I am going to do something right here called add tabs. So if I cut all the way through this, on the very last pass, the very last time this goes around, I'm going to be left with a piece of material that's fastened to the router and a piece of material that's loose, and a router driving itself. That's not a safe situation. So I'm going to add these things called tabs. Okay, so I'll select it. I'll go edit tabs, and I'll put let's put 6 in there, and I'll just click add tabs. What this means is each one of these little yellow T's is a location where the machine is going to lift up, move over, plunge back down, and leave a little bit of material there, so that profile is finely cut, it you don't have a loose piece of wood vibrating around and causing a potentially unsafe situation. So let's calculate that, and then let's preview the visible. All right, so right in there, you can see those little tabs right in here. Those are important. Cool. So I think I'm ready to go. I'm ready to run this on the machine. I've previewed everything. It looks good. We do want you to take a screenshot of this, or I think there's a button over here where you can actually save preview image. So you can actually save this image right here as a bitmap image, and that's something that we need to see, that you understand this before you can cut anything on the machine. Last thing I want to do here is I want to do a summary of all the toolpaths and the time. It's going to take 7 minutes to cut out the letters. It's going to take 6 minutes to cut out the profile. So my total job is about 13, roughly 15 minutes. That's important because we don't want to start this, with 10 minutes left of class. So having this information, usually when we're working with this, we have y'all take a screenshot of this, like a snip clip there of this, and let us see that as well. And we are almost ready to go. Last thing we need to do is we need to get the toolpath from this program to another program. And the way that we do that is right here, save toolpath. Okay, I am going to want to visible toolpaths into one file, Shapeoko inch tool change. If it's not selected, go find it in here. And I'm going to hit save toolpaths. And now my toolpath is on my G code is on my desktop. So from here, go to another video about opening up the G code and starting a computer program that the router uses, and we'll go and we'll cut this out.